So this is 5 pi over 4 here. And then this one over here, well, this is another 30 degrees here, right? So 7 pi over 6, this is going to be 8 pi over 6, which what does that reduce to? 4 pi over 3? Okay, good. So you can put those on there as well. I know that might be getting tight for you, whatever. And then, of course, the values here now, right? For this one here, we're going negative root 3 over 2, negative 1/2. And so for 7 pi over 6, the sine value is negative 1/2. Put the yellow there now. Okay, here's 1/2. Negative 1/2 there. Okay? There's positive up here. There's negative down here. Negative 1/2. See that? And then this one is going to be negative root 2 over 2, negative root 2 over 2. So that sine value is negative root 2 over 2. Okay, which is that 0.707. This one's going to be negative root 3 over 2, which is kind of that 0.86. And then what am I missing here now? Oh yeah, this one right here. 3 pi over 2. So 3 pi over 2 here, which I don't have room to write it, right up there, has, what's that? That's 0, negative 1, right? So we have this right here. Okay. So these are sort of spaced okay. And if we connect that line, that's where we get this. Okay. And then finally the fourth quadrant. I'll go a little bit quicker here now. I won't even write all these out here probably. But you can kind of see that these points map exactly symmetrical to these ones over here, right? And then you have this sort of thing happening. Okay? So that is the connection between the unit circle and the graph. The angles are on the x-axis. The actual values for the sine function are on the y-axis. So that's how you get. This is the graph now of y equals sine theta. If we look at our graphing calculators, you guys don't have them handed out here right now, so just watch up here. Let's go to y equals. Let's clear that. And if I do sine of theta, or it'll show up as x, but there's theta there, see, theta, sine of x, and I graph that, okay, see there's where we're starting at 0, it's going up to 1, down to 0, down to negative 1, up to 0. And I'd like to just adjust my window a bit, so x minimum, let's just take that to negative 1, and the x max, let's just go to 6.5. The y max, let's go from negative 1.5. Negative 1.5 to positive 1.5. Okay, so here's the graph that we just generated right here. Okay. Now this is 2 pi. How do you know? 1, 2, 3, 4, 5, 6. 2 pi is 6.28 roughly. So that's why it's 6.28 here. Okay? That's our sine. You see that? Yeah? Any questions? Okay. If there's no questions, that's great. What I'm going to do on the same graph, and I'll do this a little bit quicker, but I'm going to do sine in, let's see, purple. Can you guys see purple? All right. Oh, yeah. Purple's very vibrant on this new projector. Love it. Okay. So, I know this is a bit of a mess here now with all the circles and all my little doodles here, but let's try and keep the same page going. And like I say, we'll move at a bit of a swifter pace here. Okay. And yeah, and I'll just plot some points for cos now. Okay, so cosine is this value, right? It's the first value. And a lot of it's going to be the very same, but for 0, cos is 1. There's a big difference between sine and cos. At 0, sine theta is 0. But at 0, theta, cos is 1. So we have a big purple point right there. Okay? And as we move around, so from 0, as theta gets larger and we're going around towards 2 pi, let's follow these values. Okay? Positive root 3 over 2. Well, we said the positive root 3 over 2, right, was that 0.866. So it's right, right here. Same level as this one over here. So there's our first point. Pi over 6 is this root 3 over 2 right here. Interesting here, at pi over 4, both values are the same, sine and cos. See that? So at 45 degrees, or pi over 4, they're both the same. So guess what? Their graphs would actually intersect there. So the cosine graph intersects right here. Okay, moving along to pi over 3, we've got 1/2. So pi over 3, 1/2. And pi over 2, the cosine is 0. I'll finish the second quadrant here, and then we'll kind of see how it's going there. Okay, so the second variable, now this is where we have negative, right, for cosine. So for this one, the cosine is negative 1/2. You see how it's positive in the first quadrant, but it's negative over here because only sine is positive in this one. So we've got negative 1/2 for the next one. We've got negative root 2 over 2 for the next one. We've got negative root 3 over 2 for the next one. And then negative 1 for pi. And what you should be seeing, actually, is that the shape of the cosine graph is very, very similar. Sorry, this is kind of tough to do in this tablet, but very similar to the shape of the sine graph. Right? You see how it kind of does that little curve there? And as a matter of fact, if we continue this on, which I will, we'll see just kind of how this kind of gets mirrored. So 7 pi over 6, this is negative root 3 over 2, negative 1/2. Nope, my bad, negative 1/2, negative root 3 over 2. So 7 pi over 6 is right there. 5 pi over 4, you see this, we have the exact same values again. Negative root 2 over 2 and negative root 2 over 2. So they intersect here again. 4 pi over 3 is negative 1/2. 4 pi over 3, 1/2, right there. And then 3 pi over 2, the cosine is 0, so it goes all the way back up to 0 there. And if we can connect those dots, what you should be noticing is that the cosine graph is just a shift of the sine graph. It's just the same graph, except it's same graph, but it's just shifted over. Okay, so they kind of follow each other a little bit, and then the rest of the points would look sort of like this, right? All right, so as best we can there. That. And that's how your cosine looks. And that's all from the unit circle. And we won't talk about tan today, but we'll talk about just sine and cos and kind of what those graphs look like. Questions? Okay, let's talk just about a few of the terms that I have mentioned here already. Let's write them down sort of officially as some definitions. But in your textbook, they talk about what a periodic function is, and again, I've mentioned that. So let's just make it official here. It's a function that repeats itself over regular intervals or cycles of the domain. So it's a repeating function. Okay, a periodic function. So the periodic and repeating, those two words kind of go together. Again, that's just the MathWell notes there, a short form. But it's a repeating function. If something is periodic, like a magazine or like a periodical, have you ever heard that? A periodical? It comes out every so many months. It's periodic. It repeats. It comes out at irregular intervals. It's produced. All right. The period. Okay. So if something is periodic, what does the period refer to? It is the length of the interval over of the domain over which the graph repeats itself. So in different terms there, it is the length of one complete cycle. Okay, and this cycle is, of course, that which is being repeated. So it's the length of that interval. And on a regular sine graph, okay, just real quickly, okay, if this is what your sine graph looks like, boom. This is the length of one period, from here to there. That is one period. And why is that? Well, because, as we've seen on our graph, that this just keeps going over and over. It repeats itself. There's 2 periods. Okay. Go back the other way. There's 3 periods. You see that? So it's the length of the repeated kind of part of the graph. One full length. So either from 0 here to the other 0, the start of the wave to the start of the wave. And if those of you that have taken science, if you think of this as a wave, the crest to the crest, right? The trough to the trough, those are all period lengths. And you've heard that in science a lot. The general shape of the sine and cosine graph, the shape is called sinusoidal. That's the description of the shape. So that's for sine theta and cos theta graphs. And one more definition that you will recognize from Physical Science 20, if you took that class, which most of you did, the amplitude, okay? And that is literally the height of the graph from the kind of the center line to the top, or from the center line to the bottom. Or you could say it's half of the total height of the graph, from the very bottom to the very top. You take that height and you divide it by 2. So they say it's the maximum vertical distance that the graph of a sinusoidal function varies above and below the horizontal center axis of the curve. Okay? Okay, that's one way of putting it, but from science this is the amplitude, right? Okay. Another way I'll put it is half the total height of a sinusoidal graph. Okay, half of the total height. So if you have a maximum point and you have a minimum point, you take that total distance, and that's A, that's 2A, so amplitude would be half of that. Okay? Just another way of putting it. The book describes it like this, but it just takes a lot more words. It might be confusing. So that's amplitude. All right. Any questions so far? This 5.1 is a pretty large section. I think mainly because it's been, it's a bit of a refresh for some points. Okay, so we'll keep going. We'll keep going. I'll do some continue the instruction because, like I say, it's a big section. They want to talk about amplitude next. Okay, so you have seen this, and I think I'll take this moment to hand out some graphic calculators. But we're going to talk about y equals a sine theta and y equals a cos theta. All right, so with your graphing calculator now that